Pre-Algebra, Mr. Lawrence here with your flipped lesson for Tuesday, February 28th. We're going to review very quickly cones and pyramids. All right, we'll start with pyramids. And remember, to find the volume of a pyramid, it's just like finding the volume of a cube. You find the area of the base, multiply it by the height, and then you're going to need to divide it by 3. And you saw why in class today. All right, to find the surface area, you're going to have to break the pyramid up into its basic shapes. In a typical square-based pyramid, you're going to have a square, and then you're also going to have 4 congruent triangles. All right, so you find the area of each of those and add them all together. Of course, you could have a triangular pyramid, you could have a hexagonal pyramid, or whatever the case may be. The number of triangles will always match the number of sides of the polygon that the base is. Okay, so let's just do a standard square-based pyramid. Okay, it's kind of going like that. And then let's see here. All right, and then I'm also going to need to include this piece here. And I'm going to put that at a right angle. The right angle should be acute to you. What is that? That black little segment is the height of the pyramid, not the height of the triangle. Okay, it's the height of the pyramid. And in green, I'll go ahead and put this one in. That little guy is the height of the triangle, or of each face. Okay, now I need to give you some dimensions. I told you this was a square. So let's make this, say, 14 millimeters. And it is a square. Okay. And hold on one second. I'm going to make the actual height of the pyramid. The height of the pyramid will be, well, that's 14. We'll make that 16 millimeters. All right. Now to get that green segment is really easy. I'll just use my old friend Pythagoras. You see it? Now you don't have to do all this work, but I'm showing you how I get it. I know that this is 16. That's 14. That's x. I'll do 14 squared plus 16 squared, and that'll equal x squared. So I'll take a minute and solve that. I'll be right back with you. It comes up to be 21.3 millimeters. All right, 21.3 millimeters. Now again, you'll be given most of this information in a problem. You won't have to derive it all. Although it could be on the OEA, they could do something like that, where you have to find the slant height of the pyramid. Right. Hopefully we're still recording with sound here. Anyway, so let me find the volume of this pyramid first. And remember, to do that, I'm going to find the area of the base, multiply by how tall the pyramid is, and I'll divide by 3. Well, the area of the base is a square, so that's going to be 14 times 14, right? Because the base times the height of the square. And then I'm going to multiply by the height of the pyramid, which is 16, and then I'm going to divide by 3. I didn't give you very nice numbers, unfortunately, but it doesn't matter because the OAA might not give you nice numbers. 14 times 16, and I'll divide that by 3. And we end up with the volume of the pyramid being about 1,045, 3 repeating millimeters squared, or 1,045 and 1/3 millimeters squared. Okay, remember we have to divide by 3 because a pyramid is 1/3 of a cube. All right, now to do the surface area. Well, I know I'm going to have a square, and the square is 8 by 8, right? No, it is not. It's 14 by 14, excuse me. 14 by 14. All right, and 14 squared is 196 millimeters squared. All right, I know I have 4 triangles, but all the triangles are congruent to each other, right? And I know that this side here is 14, and I know that the height is 21.3. 21.3 millimeters, right? And the area of a triangle is the base times the height divided by 2. So I'll take 14 times 21.3, and I'll divide by 2. I can do this really quick in my head because I know that 14 divided by 2 is 7. So I'll get a 1, carry the 2, that'll be a 9, and a 14. It should be 149 and 1/10 millimeters squared. But there are 4 of those. So I could take 196 plus 149 1/10 4 times. Or, because I'm getting tired of doing this the long way, I could multiply 149 and 1/10 by 4, add it to 196, and that would give me the same answer that way. A little bit less work. I have to think about what I'm doing. Okay, let's see. 1, 2, 3, 4 is 36, and 6 is 242. I'll carry the 4. I've got 1, 2, 3, 4, 5, 20. So that'd be 9. Carry the 2. 1, 2, 3, 4, 5, and 2 is 7. 729 and 4/10 millimeters squared. That is the surface area of the pyramid. Okay, piece of cake, right? All right, let's go on to cones now. Cones. We'll get some practice with this tomorrow. Our cone might look like this. Okay. And I'm going to need either the radius or the diameter of the cone. I'm going to give you the radius, and I'm going to tell you that that is going to be 5 meters. And then I need to give you the height of the cone. And let's see, we'll make that 30 meters. Okay, you're also going to need the slant height of the cone, and I'm going to use Pythagoras to figure that out again. I don't know if you can see it. The triangle that looks like this in the shape, the slant height is the black side. So that's the hypotenuse. So I'm going to go ahead and use Pythagoras to figure out squared minus 25. Looks like that slant height is about, and I'll write it over here, 29 and 58 hundredths meters tall. Okay, it's a pretty big cone. All right, maybe it's a storage cone. They're storing salt in it or something like that for the highway on the turnpike. Okay, now the volume is pretty easy. The volume of a cone is just like doing the volume of a pyramid. All right, except that your base is a circle. So I have to do the area of the base, multiply by the height, and I'm going to divide by 3. Well, the area of the base is a circle, so that'll be pi r squared times h, the height, right? And I'm going to divide that by 3. Well, pi, we use 3.14 for an approximation. The radius is 5, and the height is 30. And I'm going to divide by 3. Now, again, you know, instead of dividing, I can go like that and say, well, that's 10. If you don't want to do it that way, you don't have to, but I think it makes the math a lot simpler. So 3.14 times 5 squared times 10, and it looks like the volume of this cone is going to be 785 meters cubed. 785 cubic meters. There's the volume. Now the surface area is kind of strange, because remember, the flat network for the cone looks kind of like that. And the only way to really see that is to take a cone apart. It's kind of hard to visualize it. All right, so to do the surface area, I'm going to need the area of the circle here, which is pi r squared. But the area of this guy is pi r L. And remember, L is the slant height. Okay, so the shortcut formula that I was singing the other day was the surface area of a cone is pi r squared plus pi r L. Oops, excuse me. Okay, so I believe my radius was, did I give you a radius? No, I didn't even give you a cone, did I? So let's do this cone. Oh yeah, I did. It's back up there. Excuse me. All right, so there's my, where's my cone? Cone, there you are. My radius is 5 meters. So I'm going to have 3.14 times 5 squared plus 3.14 times 5 times the slant height, which I used Pythagoras to find, which was 29 and 58 hundredths. So it'll be 29 and 58 hundredths. All right, and I'll use my calculator to help me do that. So I'll get 3.14 times 5 squared plus 3.14 times 5 times 29 and 58 hundredths. And my surface area will end up being 542, and I'm going to round it to 91 hundredths, and that is meters squared. And there you go. It's really just a plug and chug problem. You have the formula and you just stick it in. All right, you could explain why, but it would take, I believe it would take calculus to really explain it, dealing with surface of curves like that. And I'm very rusty on my calculus. It's been many, many years. All right, Mr. Lawrence signing off. Have a good night, everybody.